Chamero. I'm going to do a quick overview of using PostGraphile with GraphQL to kind of build out a user address form, just to sort of showcase how you might duplicate Amazon's address form. So we got a couple fields here for an address. We got a full name, address, city, state, zip code. We can actually go real quickly look at the new address form. Some interesting things we observed about Amazon's address form is like the max length. These make it really easy for me to kind of decide what the max length should be, or like how I want to validate inputs. So we kind of just built out this quick form. We made some fields required, some have max lengths. So when we try to submit the form without fields, they will not let us. Let's see, what's a good address? First floor. We can call this Houston, Texas, 77012. This checkbox is not working right now. This is supposed to be a checkbox. For instance, though, like one cool thing, this zip code is using a pattern. And so it just regex that it's either like a 5-digit or 9 digits separated by a dash. And we can actually just test that out real quick. And so this title field actually shows us, the title field on an input allows us to give the user like some sort of information on why that specific form didn't validate. And some background is this is a checkout form for a project I'm working on called JTX. So hopefully someday you will use it. You will be a user. So some interesting things here is, and I'm saying that a lot, some interesting things. Without getting into the weeds too much here, PostGraphile is a library that gives you a full GraphQL API based on your schema. We can pop over to here to GraphQL, and we can see everything we can query. We can see, things we could make mutations on. So like, if we wanted to create a new user address, we could just pop this in here and it'll automatically give us the mutation. If we wanted to, go see our other addresses, we can start the checkout form over and we can kind of see this, this is actually the house of the Wright brothers way back in the day. This data actually comes from the checkout has a top level query. And one of the fragments that we put on here is the shipping addresses fragment. And so essentially we're just saying there's a component called shipping address and these are the addresses. We can see what that fragment looks like. And essentially this fragment is on the query, or it could be on the viewer, but that's a different discussion. And throughout this component, the shipping address has all the fields we want. When we're making a new address, the mutation also uses this same fragment. And so this kind of just keeps us from having to retype that everywhere. So before we kind of get onto the database part, the stack is also running GraphQL CodeGen. And so GraphQL CodeGen watches the schema that comes from PostGraphile. It's automatically generated based on our database. And it watches for anything with a .graphql file. And so this checkout query and this mutation automatically, the checkout query, which has the user addresses, we automatically get this use checkout query. It automatically generates that. It's beautiful. It's all typed. I just command clicked that function, and it took me into this file called GraphQL types, and there's this very confusing function, but essentially we get back, when we call this function, we get back loading, which is true or false, data. We also get back errors, or an error. One really nice thing is if we try to use something that's not defined in that GraphQL query, like TypeScript automatically tells us, first off, TypeScript tells us what's available, right? So I showed you that checkout query a minute ago, and there's a couple things on that checkout query. There's orders, there's user address primary, and there's user addresses. And so like we can just keep going all the way down. So nodes is a concept of GraphQL, but we won't go into that too much right now. And so like every user address has these fields that we just talked about in the fragment. And so like now we know that street 1 is there. Data is not always defined, right? Because it could be loading. And so we'll just do an optional training. What's nice though is like I said, this field is not, it doesn't exist. And so we can see this is the type that we're getting back, that a user address node has this type, and ADS, whatever this nonsense is, doesn't exist on there. So circling back, we're trying to build this new address form. And we wrote a mutation earlier. And we can actually use so the mutation is to create a new address. And so we automatically get these types that are also generated from GraphQL. And so we can define a new state that's just an object, and that object is going to match the shape of the user address input. And so full name is a string, which, once again, comes from GraphQL, and GraphQL is automatically generated from the database. And so the database full name, if we go over here real quick, and I promise you we're gonna look at the database real quick, but that's probably the heaviest part. Full name is a varchar. It's basically a string. And so once again, TypeScript is really nice because it's gonna complain. It's gonna say like number is not assignable to string. And even more so than that, if we're missing any variables, this whole thing means it's not matching the shape of the user input. So this state matches exactly what the use new address form mutation expects. Okay. And when we submit the form, when we hit this submit button, I like to follow sort of vanilla HTML standards, right? And so this is one of those things where I kind of wish they could see me, or wish y'all could see my video, but that's maybe I'll have to think about doing that later. Well, no, they can't. By the way, my friend Aaron is on, but y'all can't hear him. I'm a big fan of following just raw HTML standards. And so rather than having the on submit be on the submit button, when we call submit on a button with type of submit, it submits the form. And so we call the mutation and we pass in this state that's typed by the user address input. And once again, this new address, that mutation function, it's automatically generated from this new address form, which is in turn generated from the GraphQL schema, which is generated from the database. And so that's just a quick overview of like, you know, the user has more than one address, the user wants to add an address. And so how does all that stuff get generated automatically without us having to write like GraphQL resolvers or anything as well? We just define this user address table. And I'm using this thing called GraphQL Migrate. And so if you watch my logs, you know, if I change anything in here, well, we're running a little slow right now, probably because I'm recording. Oh, and I wasn't at the bottom of the thing, but you can see this finished in, you know, this many seconds. Basically, if now that we're looking at that log again, we'll see it get called. Yeah, and so it's running the current SQL file, which is this current SQL file. So anything in the current directory will automatically get ran. And so, you know, the first thing we do is drop the table, and then we recreate it. And so anytime we make changes, this whole SQL file is going to get executed again. This user addresses table, it has a UUID for the primary key. It has a user ID, which belongs to the users table. And by default, the user ID is always going to come from the current user ID, which is automatically, it sort of gets populated based on so PostGraphile is running it on an Express server, and we pass a cookie to it. And basically when it talks to the database, it says like the user ID, we're looking up the session, and then whatever the session's user ID is the current user ID. I know that's a little confusing. But essentially anywhere in our SQL, we can just call current user ID, and that when a user is making a GraphQL request, we're just going to default to that user ID. So I mentioned earlier, Amazon had I was looking at Amazon's form, and I was like, okay, they got a max length of 50. And so I did the same thing. I just said like this input should have a max length as well of like 50 or 60 or whatever. It's also required, and that's how I got all those those validation forms, which is kind of free with HTML5. And the thing though is that's just the client, right? So somebody could just make they could log into the app, pull their session cookie out, and just make a GraphQL request with that cookie, and then they could still put whatever values they are. So we still need to protect the backend. And so each of these fields, like full name, street name, city, state, we can actually just run the exact same checks. And I mentioned earlier the zip code has that regex, and so we can also do a regex check here. And so we've got a pretty nicely protected table. PostGraphile, the way it knows what to expose and what it can expose and what it can't is by using Postgres's row level security. And we'll pause here 1 second and we'll talk about a bunch of other alternatives that sort of kind of give you maybe a backend and a GraphQL API. And me and my friend Aaron were talking about, my friend Aaron and I were talking about this earlier, and it's just that SQL, it goes back to the 70s. It's not going anywhere. When you're learning like these newer libraries, I'm not going to name any, but like those aren't very transferable skills, right? SQL, even if you're not using GraphQL, like you'll still find a job that requires SQL. And so that's just a little side note. So in Postgres, there's the concept of triggers. And so before insert or update, we basically call a trigger. So before anything gets updated or inserted into the user addresses, we're going to call this, we're going to execute this function called trigger tg __ timestamps. Basically any functions that we're really only making to run as triggers, we can kind of like prefix with tg __. And this trigger timestamps basically just updates created at and updates created at and updated at. I think that is actually, we might be able to peek at that function real quick. When you're using this kind of stack, you really need to have some IDE and tools. The IDE being your program that it's like your Photoshop for code. One of the big things is like I have this database browser, and this is like super important when working with this kind of stuff. And I'm like recording a bunch of stuff right now, and so everything's going really slow. Maybe it's better if I just do a quick search. So most of my auth and logic kind of comes from PostGraphile or PG starter. No, Graphile starter. It's like a SaaS boilerplate that the PostGraphile team wrote. And like, I just basically copy and pasted their initial schema just to like, that's the easiest thing. And that they're the ones that wrote this trigger timestamps. And so I was going to search for this trigger timestamps in the initial .sql, but instead, since this finally loaded, I'm looking at app private. So we have a couple different namespaces. App public is everything that's exposed in the GraphQL schema. Private is stuff that we don't want to show. And one of those things is TG timestamps. And it's like a pretty simple thing, basically. This timestamp says like the new row, if we're updating it, you know, we're gonna use the created at time. I don't know, this is a little confusing. Just, this is what the trigger looks like for TG timestamps. You can investigate that more if you'd like. That's all that's getting called here. And that's basically on everything, right? So almost every table that we're going to expose to GraphQL is going to have row level security enabled and timestamps. PostGraphile has a strict mode where it's not going to present queries that aren't fast. And what I mean by fast is there needs to be an index on it. And so like if there's not an index on it, if this orders table, which I'm not going to get into right now, if this orders table, if I didn't index that that column, it wouldn't show up as a GraphQL query. And I could show you that maybe in another talk, but like we're just trying to really get through this addresses really quickly. Actually, maybe on the viewer, right, there are user addresses. And if we comment this out, yeah, if we commented that out, you'll notice user addresses is nowhere to be found on this viewer now. There's user emails and user authentication list and all these other things. And all we have to do is we just add this user index back and boom, there you go. We can now query viewer addresses. So PostGraphile is really smart about those things. Another thing is for an address, right, they can only have one primary address. And so this is a unique composite index. And so basically we're indexing the user, and like what you can think about an index is it's we have like thousands of rows in our database, right? But like we can make an index is basically a smaller table. And so it's like that table only contains user IDs where primary is true. That's how you can think about indexes. And unique indexes at that. I'm still not quite sure about why this one is required. If we're creating this unique index, but I noticed that they did it on the user emails table. And so they know more about database design than I do. I forget his name. He's a super nice dude. He's always on the Discord, and he'll totally respond to you. Let's see who's in here. Let's see. Sorry, I don't even know how GitHub works anymore. Oh, Benji. Benji's his name. He's a cool dude. He basically did all this. So we talked about indexes, right? And I almost always try to create this row level security and trigger and indexes. I try to always make them in the same order. That way I can just copy and paste like another table and just get it moving very quickly. But so we did indexes, and so now we enabled row level security, and so now we're gonna create a policy. And basically we're gonna create a policy called select own on user addresses. And basically it's saying like you should only be able to select your own addresses. Like it will never show you anybody else's address. And we could also say like, is user an admin? And then it would return all the addresses. That's a different conversation though. And then we say a user, when we insert a new user address, the user ID must match the current user ID. And then we grant this to the database visitor, which is the Postgres database itself has different roles. Basically users that can access the database. And so one of those users is a logged in visitor. So furthermore, we can restrict what fields a user can modify on the user addresses. And once again, this database visitor, we could instead have database admin, and like then we could have a different set of security policies for an admin. So what's really cool about this stack is like, so we're talking about how this Graphile Migrate is like really fast. And then it automatically updates the schema that gets committed. And what's nice about the schema getting committed is like in CI, I can run type checking. I can just generate all that GraphQL generated stuff because you don't commit that stuff. It's just a generated file. I can run that without starting up a whole database. But that, I'm losing my train of thought. We're getting a little roundabout here. Essentially, these are the policies. Grant insert, right? So why is this important? Well, a user can only insert these fields. There's an is deleted column. We don't actually want users to be able to delete an address because like, what if they have an order and it's already shipped, right? And we just delete the address, and then like we can't, like if there's a problem with the order and they call us and they're like, hey, my order never came in, and like, well, we don't even know what address it went to. And so that's what's called like a soft delete, and we'll just hide these rows from the user. That logic hasn't quite been implemented yet, but we don't allow them to modify that field. So one cool thing about this stack, I think what I was trying to get to earlier, is like if we write a mutation, we can say create user address, right? And these are the fields that are necessary. It's already added the necessary fields. Basically, what I mean by necessary is these fields are not null, or they don't have a default. One cool thing, like what I'm trying to get at here though, is like if you notice, if I remove these insert fields, Graphile is really smart, and it just immediately, well, yeah, there we go. It's a little slow. We notice now it only lets us insert full name. So one other cool thing is this is called a computed function, and basically we can write a function that sort of has the table name. Well, the function name is what will show up in GraphQL query. And so essentially the user address primary is the name of this computed function. It's not actually like a table, or it's not actually like a column. You can add computed functions for columns and returning like queries. Essentially this function returns a user address, and then we select from the user's address which one is primary, right? And like part of me was tempted to implement this on the front end and just run like a find, call dot find on the user addresses array and just find the one that's primary. But like we can move a lot of this logic to the back end very easily. And so this user addresses primary query is just always going to return the one that is primary. And you know, that's kind of important in our React component, which is the shipping addresses. Essentially, the kind of the logic here is like, if the user doesn't have a primary address, like if address picker is not open and primary address, let's just show the primary address. If address picker is open and the total count is greater than 0, we'll show the address picker, which says like you have multiple addresses. And if none of that's true, we just show the new address form. And so this primary address is like a lot easier to manage. I don't know how far back we would have to go to, yeah. Basically, instead of having to do this on the front end now, the back end just does it for us. Props, user address nodes find. And so that's like a really interesting usage of computed columns. I'll have to get back. I don't know. I totally, actually, primary, user address primary. A little side note, I mentioned those fragments earlier, and so you can actually have the shipping address props are these viewer addresses plus, and it's also extending that shipping address fragment, which gives us these types very quickly. And so you can kind of give each component a fragment rather than writing like one huge query. You can just like, you know, this component has this fragment, this component has this fragment. Those are called co-located fragments or queries. And you can just see like we're spreading these fragments. It looks just like the spread operator in JavaScript. Let's get back to this. So we mentioned triggers earlier, and I kind of went through the nuance of like the trigger timestamps, just to give you an intro before we get to the trigger primary address. And we sort of wrote this little note about like what the logic of user addresses should be, and like a user may have more than one address. Editing the address at this point is not allowed because I don't want to implement editing addresses. They can be soft deleted, and then if existing primary address is found, a new row is primary, old row is updated to not be primary. And so that's what we're handling here. We're basically saying, hey, I already have a default or a primary address, but I checked make this my new default address. And that's actually going to fail. if you already have a user address. And so some of the really hard things about working with this stack is like debugging and like figuring out how to test like something like this. So I'm going to just give you a quick overview of how I would go about how actually I just went about writing a trigger primary address. So all of my data comes from these seeds. So I don't have to sit there and like manually create data every time. And like if other developers come on, they just like automatically have a test user, that sort of thing. One of those things is user addresses. And so like we're going to insert into user address is primary true. Like basically I'm this user, like the user that is me. I guess I should give you like some more explanation on inserts. One like a cool thing about this is that like rather than me having to know what the user ID is for my user in CRMRO, I can just run a select right here. And so this is going to return that ID. And essentially I already have a primary address. And so I'm not normally going to leave this second insert. I'm only doing that to test this, this trigger that we're writing. And so the concept, like a variable inside of a function, we write in a declare, and we can declare all the variables we want. So like we could also just say like name is a varchar, a variable character. So we've defined one variable called primary address. And so the first thing when this trigger gets called, it gets called before insert or update. And one interesting thing to note is like, you might notice these triggers are prefixed with a number, and that's because they're ran in a specific order. So this trigger has 200 and that timestamp has 100. So this thing gets called after the timestamp trigger. So the first thing we do is we do a lookup. We say select what, like this star means select all the variables. And we select all those variables into the primary address variable. And we're selecting them from the app public user addresses table. And we're saying, find me the user address where user ID equals new user ID. And new is sort of like a global variable inside of this function. And it's basically saying like, if we're inserting or updating, new is basically the new row. And if we're updating, there's going to be a function called old, or a variable called old. And so basically we're saying like, find me this, we're inserting this row with this address is a row that we're inserting. It has a column that is user ID. And we're saying like, find me any address that is also primary with the same user ID. And we're inserting it into the primary address. So this function took me a little while to debug. And I'll get to like what went wrong there, or I'll just tell you right now actually. So previously I thought since new is primary is true, like I just had this, I didn't have the is true part. And we can actually see like I just broke it when it runs the migrations. It's saying like, well, hold on. Oh, what? Oh, shoot. Hold on. Got to fix this thing. All right, there we go. So when I was writing this function, I didn't have this is true part. And we can see this is going to fail since we're trying to, that seed gets ran right after the migrations happen. That's weird. let's see what's going on here. Essentially, like, yeah, it should be raising an exception right here because we're trying to insert a user address for a user that already has a true, which this is super weird. Let's see. All right, let's say is true. That's so odd. Let's try this one more time. Okay, this is what I'm trying to show you. Duplicate key violates constraint. Wow, this is totally throwing a wrench in my demo. Is true. Oh, I wonder. That is the oddest thing. Well, I'm just gonna manually call this again, and we're gonna see that this insert will now pass, hopefully. Oh. I'm gonna have to edit this down, I think. Yeah. Yeah. I'm probably gonna make it like be 2 parts. Yeah, my whole everything's kind of freezing up for me right now. Oh, look, it finally fired off. Okay. So this is what this this trigger function is basically supposed to say, like, if there's already a primary address, we want to set that address to not be primary anymore, and we want to set the new one to be primary, which it already is because new is primary is true. And so, like, now this thing didn't show up, right? Like, this unique user address primary, this unique constraint is no longer failing us. But like, what was really confusing is like this whole, I expected this to work, and I guess maybe I don't know. The whole point here though is like, how do we debug these functions, right? There's not really like a great debugger for inspecting the database. So one thing we can do that's, rather than watching the database logs, we can actually just call a raise exception anywhere. And this will like stop this whole thing. And so essentially you just say raise exception, and then we give it like a, and then this percentage sign is a variable that comes from whatever our next argument is. And so we can say, we just want to see the value of primary address. And so next time this migrate runs, yeah, we can see primary address is actually null right now. That's the reason it's null is because we're inserting multiple addresses in that seed file. I think what would be better here is to say like new is primary, right? Or better yet, we'll just say like new for the whole thing. And so we're raising an exception that says A, and now we can see the row that's not correctly getting inserted. The logic that I was having trouble with is like, I was just putting new primary without the is true. And so we can very quickly say like, we can test logic out here, right? We can say like new is primary, and it's going to be true, but like, so is it false? And we're going to see, I think actually earlier, the problem I was having showing the error was I just wasn't scrolled down far enough. But so new is primary is false is false. And so essentially that's how we handle sort of debugging logic in a database trigger. I don't know. Do you think there's anything else? Yep. Coolio, guys. If y'all have any questions, just throw them in the comments, or you can find me on Twitter at NCRMRO. But yeah, thanks for watching.